Hi guys, welcome to the tutorial for designing the lever component of our speculum. So the lever is one of the most important components for our design, and it is essential for the button locking mechanism, for the top bill, and most importantly for the zip tie locking mechanism that opens and closes the two bills and holds it in place, as well as adjusts it for size. So here's how the final finished part will look like, but now I will walk you through all the steps that gets us to this final design. So first we start on the top plane, and we first create the top head. This is the base structure for the lever, which holds the top bill in this area. And is composed of two arcs. The arcs are of radius 0.75 and 0.63 and extruded blindly 1.25 inches to make a half circle head. So next we take the left face of the lever and we extrude a long rectangle of 2 by 2.70 by 0.25 inches, and it is connected to the head at 120 degrees. And it is extruded blindly inwards for 0.125 inches. This is then mirrored about the right plane to create the right face of the lever. The two faces, as you can see, are mirrored here along the right plane. Next, the two faces are connected by a bottom face, which is 0.98 inches wide, and extruded up to the surface of both the lever faces. So this creates a bottom face for them and connects them together. Once they are connected, we need to cut them in the shape of an arc. This is done by cutting an arc of radius 0.63 inches, and it's cut through this bottom face along with a 0.45 inch wide indentation that is 0.07 inches below the arc. This indentation is what locks each of the zip tie ridge when opening or closing the bills. This indentation also has a slanted groove, which I will show you here. This groove is essentially a triangle of 0.13 by 0.18 inches that is cut in both directions. This groove helps hold the lever in place and allows the lever to slide to the other ridges of the zip tie in order to change the size of the speculum. The bottom edges of the lever are then filleted with the radius of 0.75 inches, and then the bottom edges of the front of the lever head right here are filleted for a radius of 0.25 inches. Next, we need to make cylindrical extrusions off the side of this the right face of the lever, and these cylindrical small cylinders are what are made to connect this entire lever to the handle component of our speculum. These cylinders are designed by extruding a 0.15 inch diameter circle that is 0.13 inches from the top edge of this head by a rate and it is extruded 0.5 inches out as well. These are then fitted into holes that are cut into the handle. So the lever also needs to secure the buttons and the button casing, And to do this, we need to incorporate screw holes into the side of the lever in order to combine it with the button and the entire button locking mechanism. Our design employs the use of a binding head screw size 1 screw, and it is using Hole Wizard, we bore 2.38-inch holes for this screw type on this right side of the lever. In order to secure this cylindrical extrusion, we need to extrude a 0.55 circular diameter surface in order to hold this cylinder in place. Without this, it's too close to the edge and might easily break off. We then cleaned up this circular portion by cutting the top portion of the cylinder through the entire right face of the lever, as you can see here. We got rid of this top portion to clean up the entire lever shape, as it looks like this now. We then mirrored this onto the left side as well. As you can see here, it is mirrored above the right, over the right plane. Now all the edges around this lever head are filleted with a radius of 0.15. As you can see, we have filleted all of these edges, except for these first two that were already filleted. The rest of the edges surrounding this lever head are filleted with a radius of 0.15 inches. Now we need to make the chamber that holds the button lock, spring, and casing. The chamber is 0.16 inches high, 0.60 inches high, and consists of a 1-inch long arc that is 0.75 inches high from the surface. It is extruded 1.2 inches back, but not all the way to the back edge of the lever. As you can see here, it's only extruded partway. The top edges of the chamber are then filleted with a radius of 0.35 inches to round the surface of the casing of the chamber. Next, we need to make a hole to fit the button in and inside this chamber. So first we need to make a reference plane. This reference plane is made as a midplane equidistant from both the front face as well as the back face of this entire lever head, or this entire chamber. So it is made equidistant from the two so that we can make a hole for the button to sit in. This hole is actually is in the shape of a square. It is 0.75 inches wide and 0.55 inches high. Since it is a square, the cut is 0.75 inches through the reference plane. And it's cut mid-plane, as you can see here. So inside the chamber, we now have a square-shaped hole for the button to sit in. The chamber also needs to hold a spring that needs to rest underneath the button inside the chamber. In order to achieve this, we need to make a circular cut to fit the spring inside the hole for the button. To do this, we need to make another reference plane that is tangent to the top surface. I will show you here. It is tangent to the top surface of the hole that we just cut for the button, and it is parallel to the top plane of this entire part. From this reference plane, we can then cut out a circle of 0.42 inches in diameter, and we cut it 0.05 inches below the surface to make a small indentation in the bottom of the buttonhole. We then fillet this circle edge with a radius of 0.05 inches to create a nice groove for the spring to sit on. As you can see, there's a little rim around the circle that the spring can sit in now. Next, using convert entities, we are able to, on this groove, we are able to extrude it 0.225 inches down from the surface and create a nice cylinder that will hold the spring in place. I will show you from what it looks from the bottom. So the spring will sit in this circle groove in between these two circles and be held in place. The face of the cylinder is then also filleted with a radius of 0.05 inches, as you can see here, thus creating a nice little cylindrical groove for the spring to sit in. So now this is the final design that I showed earlier of our lever, and we have made sure that it has all the functional capabilities that we hoped for it to have for our speculum. It functions as the locking mechanism for opening and closing the speculum bills by fitting with the ridges of the zip tie through this indentation here, and it also functions for holding the top bill and its button locking mechanism with its top chamber that houses the button, spring, and button casing. I hope you enjoyed the video, and thank you for watching.